Today's lesson is known as volume, disk method around the x-axis. The concept of finding the volume is very similar to area under the curve. When we calculate the area under the curve, we calculate the area of a rectangular shape and make the width so thin to a point it makes a line. And when we gather and stack those lines together, we have something called area under the curve. But when it comes to volume, we're going to find the area of a shape. In this case, we're going to take the area of a circle. And if you take a second area of the circle and stack them on top of each other, and slowly stack them on top of each other, you will see slowly forming a shape called cylinder. And as you stack more and more of these circles, the cylinder will get bigger and bigger and bigger and bigger, creating a third dimensional shape. So now we understand the basic concept of what volume is and how volume is created. Let's take a look at this example. So let's say we have f of x from A to B. Let's say we want to rotate that area around the x-axis. So that means you're going to have a circle forming since you're spinning around the x-axis. In fact, you're going to have infinite amount of these circles forming and stacking on top of each other just like we talked about before, forming a third dimensional shape where each of the area is different and it follows the f of x to the axis of rotation. So if they're continuously spinning around the x-axis, you should be able to visualize it's going to form a shape like an egg. So the volume equation will be pi times r squared times w. Pi r squared is the area of the circle that is forming over and over and over from point A to point B. W is the width of these circles. So you have infinite amount of these circles forming, which becomes your width of your shape. And if you convert this to the calculus term, volume will equal to pi times the integral from a to b, r of x squared dx, where r is the radius of the area of the disk. And this is how you calculate the volume of a solid known as the disk method. Now let's look at example 1. Find the volume of the solid formed by revolving the region bounded by the graph of f of x equal to 3, x-axis, x equal to 1, and x equal to 3 about the x-axis. Here's a sketch of f of x equal to 3, and here is the area that you want to rotate about the x-axis. You should be able to visualize the shape of cylinder, where your radius, your function, which is f of x, to the axis of rotation. In this case, it happened to be your x-axis, so your radius will come out to be 3 minus 0. Now that we have our radius, we could see that this is a disk method because when you rotate around the x-axis, it will form a nice solid three-dimensional shape. So our volume will equal to pi times integral of 1 to 3. Since you're finding the volume from 1 to 3, our radius being 3 square dx. In other words, we're integrating 9 dx, and integral of 9 is 9x, and solving from 1 to 3. So volume will come out to be 18 pi as your answer. So now let's look at the next example. Find the volume of the solid formed by revolving the region bounded by the graph of f of x equal to x to the third, x-axis, x equal to 0, and x equal to 4 about the x-axis. Once again, here's the graph, and we're going to rotate this about the x-axis. You should be able to see a circle forming around the x-axis. Once again, our radius is our function to the x-axis, since our x-axis is where we're rotating the volumes around. So it'll be x to the third minus 0, which happened to be x to the third. And you should be able to visualize the shape is like a horn. You should be able to tell there is no gap or hole within this three-dimensional shape. Therefore, you're using the disk method. So now our volume equation will be pi times the integral of 0 to 4. Our radius was x to the third, that's why it becomes x to the third to the second power dx. And if you simplify it, it'll be pi times integral of 0 to 4 x to the 6 dx. And we know the integral of x to the 6 is x to the 7 over 7. And evaluating this from 0 to 4. And your answer will come out to be 16,384 times pi over 7. Okay, to summarize what we just talked about, the disk method is used when you have a three-dimensional shape that is solid, so there should be nothing in between, no gaps and no holes. And your radius is the area of your disk.